Hello, math humans. We're going to do 2.3a today. We're going to be talking about measures of spread. So our objectives are that we're going to be looking at percentiles in a 5-number summary, which is the min, the max, Q1, Q2, and Q3. We'll talk about those in just a moment. So instead of looking at the average, so remember in our last section we looked at measures of center. Okay, and we looked at X bar, which was the average or the mean. Okay, and remember that this was also for our sample, not the population. So sometimes instead of looking at measures of center, we want to look at the measures of spread. So we want to look at how spread apart is the data. Is it really wide or is it really narrow? So measures of spread is what we're going to focus on today. That first measure of spread that we're going to look at is percentile. So percentile, notice that it's not percentage. Okay, we're not talking about a percentage, we're talking about percentile. And I know it seems like a silly difference, but this is actually kind of interesting. So a percentile is how much data, and usually when we talk about percentile, we are talking about a percent, is below a certain percentage value. Okay, and so the easiest way I think to understand percentile is actually to give you some examples. And so I've written down several different examples of percentile. So the first example, so for example number 1, it says your SAT score is in the 80th percentile. So that does not mean, we'll talk about the not first, that you scored an 80% on your SAT. What it means is that your score is better than or equal to 80% of the people that took the test when you took the test. So it doesn't mean that you scored an 80%. It means that you scored better than 80% of the people taking the SAT at the same time. Okay? Another example. So when you are growing up, your parents take you to a pediatrician, and the pediatrician keeps track of your height and weight. And then they record those and use those as a percentile. So one of my granddaughters, I have 5, is in the 100th percentile. So that means that she is taller and weighs more than the 100% of the children that are her age. She's also projected to be 6'2" or 6'3", so there you go. All right. Another way to talk about percentile, it says if a test was out of 800 points and you scored in the 80th percentile, what was your score? We don't know what your score is. All you know is that you scored higher than 80% of the people taking the test. So you have to be really careful when you're hearing numbers. Are they talking about a percentage or are they talking about a percentile? And percentile means that you did better than that many people below you. All right, so as we talk about percentiles, there are 3 common percentiles. Okay, so the first of those is called Q1, which is the first quartile. And that means that 25% of the data falls below this value. Okay. Then second one then is going to be Q2, which is called the second quartile. It's also called the median. Okay. And that means that 50% of the data falls below this value. And then the last one would be Q3, which is the third quartile. and that means that 75% of the data falls below this value. Whew, that's a lot of writing. Okay, statistics is always a lot of writing. So as we try to move on to finding those quartiles, so to find our quartiles, I'm going to give you some simple rules to help you do that. Number one, you always have to sort your data from smallest to largest. And it's easiest if you can do it like we've done in the past, where you make over here on the left be your smallest, and then over here on the right is your largest. And we'll talk about why in a little bit as we go through. The second thing that we're going to do is we're going to find the median. And remember that the median is also going to be Q2. And then we are going to find the middle of the bottom half of the data. So by that I mean find the middle number, and that's going to be Q1. And then number 4, we're going to find the middle of the top half of your data, and that's going to be Q3. So before we do an example, sorry, this is also called a 5-number summary. And oftentimes you will be asked to find a 5-number summary. Well, the 5-number summary includes the minimum number. It also includes the maximum. And then it's going to be Q1, Q2, remember Q2 is the median, Q3, and then that is 1, 2, 3, 4, 5. So when you're asked to find a 5-number summary, then that's going to happen. It's going to be the minimum, the maximum, Q1, Q2, and Q3. So I've pre-written out our example. We're going to go back and talk about flagstaff temperatures again. Woohoo! Alrighty, and we're going to walk through, and this one wants us to find the 5-number summary. So we've done this before, but I'm going to go ahead and do it again because sometimes I think when we write, it helps us to remember the process. So I'm going to put my data in order. So I have 57, there were 4 of those, if you'll remember, 2, 3, 4. So I used 1, 2, 3, 4. Then I had a 59. And then I have, what's my next number? 63. And then I have 65, 67. And then I have 68, 69, and then 71. Okay, so as I find the 5-number summary, the first thing that I want to do is find the median, because that helps to set up all of the other data. And remember, that is Q2. So our median, the middle number, so remember there were 11 data points. So that means that this is my middle number. Just to check, there are 3, 4, 5, 3, 4, 5. So this is going to be 63. Okay. Then I want to find my minimum. That's easy. That's 57. And my maximum, whoop, somebody loves me, is 71. Okay, so there's my min, there's my max, or somebody loves me a lot, which is why we like to put our numbers in order. Now I need to find Q2, jeepers. So if I look at my numbers, I have 1, 2, 3, 4, 5. This is going to be my Q1, okay? So Q1 is just the middle number of these numbers, is 57. And then can I bring in another color? I think I have another one. My middle number up here, that's going to be Q3. So Q3 is going to be 68. Jeepers! So it's 68. Alrighty. So now I have my 1, 2, 3, 4, 5 numbers, and there is my 5-number summary. Okay? So the other thing that you often see when we talk about a 5-number summary is called an interquartile range. Okay, sometimes you'll see it abbreviated IQR, and that just means it's going to be Q3 minus Q1. So if we look at the example that we just did, our interquartile range is going to be Q3 minus Q1. So if I do that for this data, I'm going to take Q3 and I'm going to subtract Q1. So I'm going to do 68 minus my Q1, which was 57. Okay, and then I will get my interquartile. Good gravy. Somebody loves me a lot today. 68 minus 57, and my interquartile range is 11. So then I would report that my interquartile range is 11. Interesting thing, if you think about your interquartile range, is that I'm looking at the 75th percentile minus the 25th percentile. So remember, that's what those numbers represent. So as we look at our 5-number summary, and I'm going to keep that example closed because I'm going to add to that example for the next bit, we oftentimes want to have a visual representation of the 5-number summary, 5-number summary. And so we do that with a box plot. Sometimes they call it a box and whisker. Okay, so I'm going to show an example of what one looks like, and then we're actually going to draw the box and whisker plot of the data that we just managed. So with a box and whisker plot, I want to draw a number line, and I have to have a scale, and the scale is going to come from your data, okay? And then I'm going to mark, and I always want to do this above the number line, and I'm going to mark those values that we just found for the 5-number summary. I'm going to mark Q1, Q2, Q3, and then I'm also going to put on my min and my max. So the way that it looks like, it's going to be a box. This is why it's called a box plot. Okay, and then maybe it looks like this. This is going to be your min. This line right here is going to be Q1. This line is going to be Q2. This line is Q3. And then here is our maximum up there at the top. Okay, so this would be a box plot for our data, and it's a really nice visual. Sometimes the box can change, and so then we start talking about skewed data. So maybe the min is closer in and the max is closer in. Maybe my Q2 moves around a bit, okay? Or I could have a different box and whisker plot, and maybe my Q2 is way over there, and then we would start talking about skewed data, okay? Maybe I have my Q1 and my minimum are the same, and then I have my maximum at the top. So there's lots of different ways that a box plot can look, and it's just a nice visual representation of the data that we've already done. All right, so I'm going to actually bring back the number from example 4, and I'm going to add to it, we're going to do example 5, we're going to draw the box and whisker plot. So we're going to draw the box plot for our data. So because it's at the top of the page, actually you can still see it, so I'm going to go ahead and draw a number line. So here's going to be my number line. And my minimum is going to be 55, and then I'm going to do 60, and then 65, and 70, and then 75, so 55, 60, so I'm going up in units of 5, okay, and my units would be degrees Fahrenheit, okay. Our minimum number was 57, so I'm going to put that right here on my box as a dot. Okay, so 57 is about there. And then my Q1 was also 57. So I'm going to go ahead and draw a line because my Q1 and my min were the same, and I'm going to label it so I know what those two numbers were. Okay. Q2, if I go back up to my data, was at 63. So 63 is about here. This is Q2. My Q3 was 68, so it's about here. There's Q3. This is going to define my box. Okay. This one, my min and Q1 were the same. And then my maximum was at 71. So then I'm going to put my maximum, and that would be right there. Okay. So it's actually really a simple graph to draw, and it gives you a nice visual. So let's talk about some of the things that we noticed. So we've talked about it already, but we noticed that Q1 is equal to the minimum value. We noticed that Q2 is about in the middle of our box plot. So that means that the average is about in the minimum between the max and the min. And it looks like our data is not skewed. So it looks like our data is fairly equally spread out. Okay? Alrighty. So now I'm going to give you a different set of numbers, and we're going to do a box plot. Ooh, look at all those cool numbers. And we're going to do another box plot. So for example, number 6, I want to find the 5-number summary and the interquartile range of weights in grams of randomly selected M&Ms. And we'll talk about this when we get done. And then I want to draw the box plot. And then after we've done this by hand, I'm going to show you how to draw your box plot in your calculator. Alrighty, so the data that we're going to be given is 0.957, 0.914, 0.912, 0.913, 0.842, 0.958, 0.925, 0.947, 0.939, 0.920, and then 0.886. Okay? Alrighty, so there are my data, and there are 2, 4, 6, 8, 10, 11 data points, which is nice because then when we figure out our numbers, it's going to be nice and easy. The first thing that we need to do is put them in numerical order. So I'm just going to write that down for us instead of kind of working through that. So it's a little bit quicker. So I have 0.842, 0.886, 0.912, 0.913, 0.914, 0.920, 0.925, 0.939, 0.947, 0.957, and 0.958. All right, so that is our data put in numerical order. So as we start our 5-number summary, okay, the extremes are easy. So your minimum obviously is 0.842, and your max is going to be 0.958. That would be a really big M&M, okay? So then now we need to find the middle. So we need to find Q2. Remember, that is the median. So if I go down, there's 1, 2, 3, 4, 5. The 0.920 is the middle. Okay. So I'm going to write that this is 0.920. And then I need the middle number. I have 1, 2, 3, 4, 5 numbers. So this is the middle. This is Q1. So my first quartile is going to be 0.912. And then I have 1, 2, 3, 4, 5. So the 0.947 is the middle on the top side. So that's going to be Q3. So Q3 is 0.947. So now I have my 1, 2, 3, 4, 5 number summary. Okay, I can go ahead and do my interquartile range while I'm here. That's Q3 minus Q1. So that's 0.947 minus 0.912. And for my interquartile range, I get that it is 0.035, and then I identify it well. Alrighty, so let's just talk about what our data is saying at this point. Our data is saying that at this, of our M&Ms that we chose at random, it appears that the average weight of those M&Ms is 0.920. So at 0.958, that's a big old honkin' M&M. Woohoo! Alrighty, so now let's draw our box and whisker plot. So I'm going to draw my number line, and I'm going to start, I had 0.82, and then I'm going to do 0.84, and then 0.86, 0.88, 0.90, 0.92, I had 0.94, not quite long enough, 0.96, and then 0.98. So now I need to put these values on my graph. My minimum was at 0.842, so I'm going to put a minimum here. My max was at 0.958, so right there. Okay. My first quartile was at 0.912, so I'm going to draw a line right there. And then I guess I should have moved it over a little bit, but you get the general idea. My Q2 was at 0.92, so right here. And then my Q3 was at 0.947, so over here. I'm going to put it right there. And then I'm going to draw the top of the box, and then I'm going to draw the whiskers, okay? So this, if you'll remember, was my minimum. This was Q1, Q2, Q3, and then I had my maximum right here. So as we look at this, there are some things that we could notice about our data. So number one, it looks like our data is skewed left. And if you'll remember from material that we've talked about earlier, that means that my data would have higher bars on this side when we were talking about bars, histograms, and bar graphs. So it looks like our data is skewed left, okay? The median is closer to Q1, so the middle, Q2, is closer to Q1 than it is to be Q3. Okay, Q3 says that 75%, remember this is a percentile, of our M&Ms weigh 0.947 grams or less, because remember that our box and whisker plot is talking about a percentile, okay? And then for Q2, that says that 50% of our data are 0.92 grams or less. Okay, alrighty. And so then it means that we would think that the normal weight for an M&M is about 0.92 grams. So that's actually kind of interesting. So now what I want to do is I want to show you how to do this in your calculator. Okay, and I'm going to leave our numbers right here. And then I'm going to write down the steps for using your calculator. Sorry. So the first step that we're going to do is do a second memory. And I'm going to write the steps down first, and then we'll go back and do it. And I'm going to choose option number 4, which is clear all lists. And this wipes out any data because we don't want to make sure that we write data on top of data, because then that would be bad. Then I'm going to do stat and edit, and I'm going to enter your data. And for most of the purposes, we're going to put it in L1, and that is the name of the list. Then we're going to do our second stat plot, and we're going to turn it on. And then we're going to choose a box plot. Okay. The next step would be that we would do a zoom 9 on our calculator. And then the last thing that we're going to do is do a trace. So we're going to walk through this all of these calculator steps together. So I'm going to get my calculator in there. So the very first step, if I can put it where there's no glare. Okay, maybe you can see that. All right, let me make my screen a little bit lighter. Maybe that will help. Oh, there we go. All right, so the first thing I want to do is do second and then memory. And option number 4 is clear lists. The next thing that I want to do is I'm going to go in and I'm going to edit so that I can put in my data. Okay, let's see if I can get that a little bit closer. So as I put it in, I'm going to put in all of the data that we had for our M&Ms. So I'm going to do 0.842 and then 0.886, 0.912, 0.913, 0.914, 0.920, 0.925, 0.939, 0.947, 0.957, and 0.958. Oops, except I missed 958. If you make a mistake, you can go back and edit any of the individual data points. Okay, so then I'm going to quit. So the next thing I'm going to do is I'm going to do second stat plot, and I'm going to go to option number 1, and I'm going to hit on, and then mine was already chosen because I was playing with my calculator. So notice that right there, and it's hard to see because it's so small, but notice that when it's not blinking, let's see if I can move it over a little bit so you can see, when you have, it actually looks like the box plot. So it has the 5 numbers on there. So I'm going to hit enter. Notice that my data was living in L1, and it doesn't matter what the color is. So then I'm just going to keep going down. And then I'm going to, oops, I changed it to red. We'll just keep it as blue. And then I'm going to quit. So now I'm going to do a zoom 9, which is zoom statistics. And there's my box and whisker plot. And that's really cool. I guess I should put a 6th step on there, and it is trace. So if I hit my trace button and I move to the left, notice that the minimum is 0.842, and I know it's really small, but it's hard to get everything in so you can see it. If I go to the right, it goes to that first quartile, which was 0.912. It goes to the median, which was 0.92. And down here on the bottom, Q3 was at 0.947, and there's my maximum at 0.958. And theirs is much more accurate than mine, so you can really see how the data is skewed, where I have nice long over here. I noticed that Q2 is closer to Q1. It's not in the middle of the box. Alrighty, I would recommend that you practice that particular thing a couple of times because it just means we need to get more comfortable with our calculators. All right, it's great having fun technology at our disposal.